Hello, everyone. Good afternoon. My name is Ana Carvalho, and I'm here today, as usual, with my colleague Inês Almeida to present you with the first R&D session of 2023, obviously powered by EDP New, as usual. For those who don't know, EDP is the Research and Development Center of the EDP Group. We work with research and development projects at the European level, which look at innovative solutions for the decarbonization, the smartification, and the flexibility of the energy sector. As I was telling you, this is the first R&D session of 2023, so thank you for being here. We're glad to have you here with us throughout all these years. We've been organizing these initiatives since 2020 in a monthly basis with the aim of bringing together experts to discuss several topics such as the challenges that we're facing and the solutions that we're already putting into practice at the energy sector. We decided to bring you here today some numbers as a thank you note. So during these almost 3 years, we have organized already 28 webinars. We had more than 30 hours fully dedicated to research and development. These hours, we invited more than 100 guests, speaking about several topics about the energy sector. And we have this amazing number, which is we have reached more than 4,300 people. So 4,300 attendants that we had in these R&D sessions. These are amazing numbers. So thank you for being part of them.
The recordings of all the webinars are available on our website. You just need to read our QR code in the slide to be able to watch the previous sessions. For today's webinar, we want to encourage you to use the Q&A chat to ask your questions to our speakers. And at the end of the presentations, we will have the opportunity for them to answer. With no further delays, we welcome you to this event and wish you all a great session, but not without first introducing you our moderator, Gisela Mendes. Gisela is currently the head of RES Integration and Flexibility at EDP, and she has been working in national and European funded projects related to energy storage, energy management, renewable energy, energy policy, electric mobility, smart cities, and smart grids. Before joining EDP in 2050, she worked as energy consultant in a Portuguese think tank and as an IT consultant in an ICT company. Now, Gisela, the floor is yours. Thank you.
Thank you, Anna. Thank you, Nish, for the introduction. Good afternoon, everyone. So let's start our R&D session. February 2022, we all assisted Ukraine invasion by Russia, and by that time, despite the numerous commitments, notably in the multiple United Nations Climate Change Conference, the COPs, and the efforts made by countries and companies worldwide, the pace of implementation of the energy transition measures has been insufficient to keep the global temperature increase below the 1.5 degrees and to achieve the carbon neutrality by 2050. Also by that time, most of the countries were still struggling or recovering from the negative effects of the pandemic. We were witnessing the global GDP shrinking, the supply chains under significant pressure, and some of them have actually been disrupted. In addition, the inflation started to rise dramatically. On top of that, 1 year ago, it started the war in Ukraine, which not only has definitely been stressing these trends, but also uncovering the European vulnerability on gas dependence from Russia. Therefore, the energy system has also been seriously affected, with real cascading effects in all sectors, and in particular in our daily lives too, notably because of the sharply higher energy bills and fuel shortages. Since then, in order to mitigate these effects, a lot of measures were put in force, such as increasing gas imports from alternative countries such as Algeria or Norway, decreasing consumption of gas and electricity this winter through energy efficiency measures, voluntary demand response programs, electricity cuts in public buildings, promotion of renewables, and so on. However, some countries have also decided to resume coal power plants to mitigate the rising energy prices and potential blackouts. So we are in a sensitive moment. Is it reasonable taking step backwards, or on the other hand, should we escalate our efforts more than ever towards the energy transition? In these R&D sessions, we are going to revisit in more detail and discuss about the unprecedented changes that occur in the energy sector throughout the course of the armed conflict in Europe, and learn which measures have been designed and implemented focused on R&D and innovation that can play an important role to overcome this energy crisis and pushing the energy transition forward. So regarding the agenda for today, we have two presentations. The first one is about how the power system sector has been impacted by the Ukraine war by Antonio Vidigal, external consultant of EDP. And the second one, targeting the R&D challenges towards a green Europe by João Maciel, managing director of EDP New. We will also have a Q&A session in the end of our session. So the idea is to answer all the questions that you may have. So as Inés was saying, please put your questions in the Q&A chats. So with no further ado, let's move to the first presentation by Antonio Vidigal. Just a small note to introduce Antonio. So as I was saying, Antonio Vidigal is the external consultant at EDP. Previously, he was CEO of EDP Innovation. He was also board member of EDP Group and held management position in several companies of the group. He was part of the management team that set up Optimus, today known as NOS. He was also part of the team that set up Edin4, which today is part of CGI. He is an electrical engineer from IST, where he taught transient regimes in electrical machines and networks. Antonio Vidigal, thank you so much for accepting our invitation. It's an honor to have you with us today. Please, the stage is yours. You can share your presentation now.
Thanks a lot. Thanks a lot to EDP New for having me and having invited. Are you seeing the presentation? Everything is okay? Okay. Yes. Okay, so then I start. Again, thanks a lot for EDP New for having invited and for being part of this webinar. It is indeed a very interesting subject. As it has been said by Giselle, almost 1 year ago, Russia invaded Ukraine, and it had lots of implications in the power sector. One of the first things I want to call your attention for is that this was not an electricity problem in its origin, it was a gas problem. You have on the left the evolution of gas prices in 2022, on the right the electricity prices evolution, and you recognize the same pattern in both, which leads us to guess that the electricity prices have been driven by the gas prices. In fact, it has been, and by two reasons. First, that the market runs with a merit order marginal pricing, and the prices are set on a clearing price, which is where the supply curve crosses the demand curve. And as most of the times the marginal technology is gas, it is the gas which marks the price. And now how does the gas turbines, gas generation, which marks the price, and how does the gas price relate with the cost of electricity produced by a gas turbine, by a CCGT? A CCGT has roughly 50% efficiency. Normally, the correct figures are below. Normally it is 55%, but normally for myself, I use the formula on the top, which is the price of electricity on the market is twice the price of gas plus 0.4 the cost of CO2 in euros per ton. If, for instance, on the bottom, when we have a gas price of 50 euros per megawatt hour and the CO2 price of 90 euros per ton, it is easy to compute that the cost of electricity will be 160 euros per megawatt hour, which are the values that roughly we are having these days. The second point is it was a gas price problem. The second point, it was an European problem. Here, the IEA shows that it was Europe who suffered the most. Portugal and Spain went well on these stress tests. They are best position in Europe. Italy, France, and Germany suffered the most. Norway, Australia, India, and the USA much less. Therefore, it was an European problem. Portugal and Spain did well in this stress test. It was a perfect storm. The lack of Russian gas was much aggravated by huge problems in France's nuclear fleet, which normally exports energy to adjacent countries. And further to that, it was a very dry year. Therefore, we lost 82 terawatt-hours during the year of French nuclear production, plus 36 of nuclear reactors, which by bad chance had been stopped at the end of 2021, lost 64 terawatt-hours of either during the year. It was, I believe, the driest years in almost 100 years. And then this was compensated by new additions of solar, of wind, and not so good by coal and gas having run many more hours than they should. Europe, and especially Germany, had become very addicted to Russian gas. You see the picture, a huge network of pipelines made it very cheap and very convenient. Fields in Russia are very easy to explore, very low cost, a huge network of pipelines amortized during the years with a huge capacity. For instance, in blue, you have Nord Stream, which we all heard about. By itself, it had capacity of 55 BCM of gas. Translating it to the units we know better, multiplied by 10, we have 550 terawatt-hours, which I remember it's 11 times what Portugal consumes of electricity in 1 year. Therefore, huge amounts of gas being imported from Russia. Germany was and is at the heart of the problem. They, by themselves, did use a lot of gas from Russia and depended a lot on it. On the left, you see that 67% of the gas which Germany imported was from Russia, next from Norway and from Netherlands. And the question we put ourselves, what did Germany do with so much gas? Most of it was used in the industry, 37%. For what? A lot for feedstock, matéria-prima, as we say in Portuguese. It was feedstock plus combined heat and gas production. This made Germany companies very efficient, very low price. And when this problem arrived, they were so impacted that companies like BASF said that in these conditions, they could no longer continue operating from Germany. Then the next usage of gas is household heating, 31%. Remember, Germany is really cold in winter. You freeze in winter if you don't have heating. And more than 10 million households have gas heating, then offices and public buildings, then electricity here in Orange we just 12%, and then 7% district heating, which is something very particular to northern countries, where it is generated at a central point and distributed through ducts through the neighborhood. Very little in transport. How did EU react to this huge impact? EU launched Repower EU, which is European Union's plan to make Europe independent from Russian fossil fuels before 2030, not tomorrow. These years we will be using still Russian fossil fuels. Repower EU has a huge target on renewables. 900 gigawatts have to be added by until 2030. It's a huge value. Just remember that in 2021, Europe had just 346 gigawatts, and now it plans to add in a couple of years 900 more. Other than the renewables, a huge bet on biomethane, energy savings, heating electrification, 10 million heat pumps, mobility, of course, 30 million electric cars, renewable hydrogen, 10 million tons, a lot, and something very hard to do, industry electrification. An example of difficulties ahead is the steel industry, where the EU plans to reduce 30% of the production of iron on the primary route. Primary route is when it is produced from iron ore, and where it is planned to replace as feedstock coal, or it is coke, coal, by hydrogen. Europe is ahead on this line of development. And it is all happening. For instance, Germany used LNG, liquefied natural gas, to change the paradigm for themselves. And they used something I had never heard about, which is FSRUs, which are floating storage and regasification units, old ships, many times tankers, who have been reconverted to work as terminal regasification stations, a bit like doing a bit what, not completely what Sinch thermal regasification does, and some of them almost with the same capacity, which is around 6 BCM per year, 60 terawatt hours. And you can see that with this bet, Germany has completely reduced the use of Russian gas. It was fantastic what they did with FSRUs. By now, they already have 3 in operation, 3 equivalent to 3 SINs terminal regasification stations, and along next year and the following year, 7 more stations will be added. For Portugal and Spain, the solution, the silver bullet, was the Iberian mechanism. It was what made the difference. But now it is disappearing. We'll see why. It has still a huge impact in days with a lot of renewables. We have here 2 situations. One is the 28th of January, a Saturday with very low demand. Portugal in green, like Scandinavia, which we always look at them as being the aliens of the EU in terms of cost, with very low costs. We have been many times with a similar behavior. Now it is starting to increase, because as we are going to see, the mechanism is disappearing and will disappear until June. Just a note, you can see in 4 that the last Friday, which is the figure I have here on the right, there was not much wind. It is banned in dark blue, and the CCGTs gas had to run all day. It is the band in the gray, and the price on the pool was marked at every hour by gas. and we came to a marginal price of 102.05 euros per megawatt hour. This is that day. I picked just 1 hour, and the mechanism runs for each hour. I picked the 9 p.m., which is the hour of was the hour of the highest price, and we see that where the demand curve crosses the supply curve, it was at 141.2 euros per megawatt hour. And remember that what the mechanism does, that is that the marginals are paid at the real value or at real cost of the gas as 54.37 euros per megawatt hour, which was the value on that day. But the others, the inframarginals, are paid as if the gas had a theoretical value, which is assumed by the mechanism. This value started at 4 and is already at 50 and will increase to 70 until June. That is why the mechanism is disappearing. On these days, for instance, this closing for the whole day, the adjustment was negative. The mechanism is disappearing. Question, what lies ahead? First of all, a lot of renewables. And to help us think what will be the impact of a huge amount of renewables on the European sector, on Portugal, and what we'll have to do in terms of R&D, I have computed using Python what would be the daily production of wind if we had the resource of last year, 2021, and we had already 9,000 megawatts of wind. And this is day by day, and we see how much it does change from one day to the other. And it's the same with the solar. It also changes a lot day by day, from one day to the next. Again, with a different pattern. Here we have lower values in winter, and of course, as we'd expect for sun, higher values in summer. This is the graph. This figure is not easy to read, but it's easy to explain. The line in black is the load hour by hour during the year, and in blue is what we get if each hour we subtract from the load the solar production and subtract also the wind production. We get what is normally called the net load, and we see that it becomes very, very variable. And everything that is below the line of zero, we have only two options: either we store or curtail. This brings to mind, or brings to the table, the importance of seeing the ways to store excess energy, which a huge bet on variable renewables like solar and wind for sure will bring. To understand it better, because not so a graph not so cluttered, I zoom a week, and here we see the pattern of the days with weekends with lower load, that we see a whole week. And again, I subtract from the load both the hourly wind production and solar production, and we get the curve in blue. And again, a lot of it is below the zero. And again, to show that all that area below the zero, line of zero, we have only the options of store or curtail. Again, we have to know to have means of storing all this excess energy, or else find uses for it. Okay, so it can be sold at very low price. Just to understand the new challenges of that are on the way, I picked here the 17th of February 2022, which was a day with very low wind and the solar. The solar is the curve in red. If I add to it the wind generation, I have the curve in green. And then the exercise I did is I will have, it's not enough to meet the load, which is the curve in black. And then I made a choice just to test of adding to it a CCGT at constant power, 2,700 megawatts, to reach the curve in blue. And again, there are times where I have excess energy, which I should store, and then negative where I lack power and I have to use what I have stored. I have computed the CCGT constant level of production to make it minimal, the minimal usage of in terms of energy. Another source of concern to which I want to call you the attention for is for the curve. This is an expression coined by Casio in California, which Casio means Californian Independent System Operator. It's like the RAN there, or part of RAN, the dispatching. And here you have the demand in green. In the red, what was the real PV production for that day, which was the 27th July last year. And then the what if I have here is that I kept adding more and more photovoltaic, up to 3,000, 4,500, 6,000, and to see and checked how the net load keeps changing. With 6,000 megawatts of PV, and remember, in 2030, we'll have 9,000. With 6,000, we get the curve in blue. And the problem of the duck curve, to which I want to call your attention, is that when it becomes to, when the time comes to sunset, approaches sunset, there is a rate of variation of the net load very, very high. And what Casio found in California, it is very difficult to follow the net load, to compensate for the net load with traditional generation. Again, the need of fast response backup flexibility assets like batteries and pump storage. Now I would like to introduce you to what normally is called the load duration curve. In Portuguese, it is the monótona. When many years ago I joined EDP, my colleagues, my bosses used to compute it on paper, on a millimeter paper. Now it's quite easy to do it with a computer. It's a very small script in Python. On the left, you have the load diagram for a day. And then on the right, what I did, and used to be done in millimeter paper, for each I order each value of power in decreasing order. And I get the base load, then the intermediate load, then the peak load. And different assets, different generator means are needed to cover each one of them. This is a real curve. I did it in Python, as I said, for you to see the dimension of the problem which comes ahead. It's 2030, what is in the PANEC, which is 9 gigawatts of wind, 9 gigawatts of solar. Then the curve on the top is the load, it's the monotony for load, it's the load duration curve. Then I start from this one, I subtract the wind production, I get the curve in blue. Then I subtract the solar, I get it in red. And then the biogeneration, it's the light blue. And then runoff river, either runoff river, I get dark green, which is the curve on the bottom. And this is the curve which has to be met by dispatchable generation. First, see that there is 40% of the 44% of the time there is excess generation. 7.3 terawatt hours would have to be stored. 9.9 terawatt hours is the missing power, which I can compensate with the generation with the energy I've stored. And now another point here on the left. If I have, it's for my friends who defend a lot nuclear, and nuclear has very things for it, but it doesn't go very well with systems with a lot of renewables. For instance, think of a reactor of one megawatt, 1 gigawatt, 1,000 megawatts. It will only run a little more, it would only run 4,000 hours. And the nuclear reactor, to pay itself, has to work, has to have a capacity factor of some 90%. Therefore, a nuclear which has in itself has the vocation of working in base load, both from the economic and the technical point of view, it becomes very hard to dispatch on a system with a lot of renewable. Before we leave this subject, and since we are speaking about putting on the system a lot of renewables, I invite you to Google Tony Seba. Tony Seba defends what he calls 100% SWB, 100% system with just solar, wind, and batteries. And what he says is that when you put a huge amount of solar and wind in the system, you only need a very limited amount of storage. Never goes above 5 days, from 1 to 5 days, which is in the reach of batteries. What he defends. And in some ways, I agree with him, because I saw that happen in computing with Moore's law. As solar is going to decrease cost, and it may decrease in next 10 years by 70%, it will become so cheap that it will become ubiquitous. And we'll have it on roofs, everywhere, even highways, you have it everywhere, and there on windows everywhere, and there may be so much solar energy that we come to what he called the superabundant power, which in many hours will have marginal cost zero, and the system may run just on 100% SWB, solar, wind, and power. Looks a bit crazy, but just to check that it is feasible. Again, I picked October 2022, which again was a day with not so much wind and solar. And what I did, I started with black curve, which is having 11 giga of solar, which is on the PNEC for 2030. I kept, and I also considered 9 giga of wind, which also what is there. And then I started, as Tony Seba suggests, adding solar. First, the brown curve is with 20 giga of solar, the green with 30 giga, the pink with 40 giga, and what you see is that when you reach to 30 giga, which is the curve in green, we are every day meeting the load of the day, which I kept it on the 150 gigawatts hour per day that we are having this year. If I add this in 22, I add this amount of solar. If I look here at the curve, for instance, in pink, I see that I am every day much above the consumption. I have every day, even on a day of October, which will add little wind and not so much sun. Therefore, I believe that Tony Seba may be right. It's a long shot, but maybe right. And since we are at long shots, let not be just Tony Seba to put his own long shots. Let me put mine. and mine have to do with undersea cables and the supergrid. On the left, I have what I call the Iberian link. It is a provocation. Why don't we pass a subsea, an undersea cable from Iberia to the UK? In fact, UK is connected to all adjacent countries with underwater cables, with subsea cables, some of them with very huge distances. And again, and now on the middle, you should Google it. It's X-Links. Is a project which is starting. It seems to go ahead. X-Links is from a UK promoter, and what he's selling in UK is that the cable, which is, if I remember, 4 giga, will bring solar and wind production from the south of Morocco, which has a huge resource, and go and be transmitted to the UK using an underwater cable, a very long underwater cable. When it is finished, will be the largest. There is another one being planned between Australia and Singapore. And my provocation here, why don't you speak with X-Links and make the cable stop at scenes where it could get solar and could get our access of renewable energy, or the Portuguese access, and perhaps also the Spanish access. And on the right, it is the supergrid, which is a project which has been around for years, and I think would make the difference, would integrate the electrical market, because this is a grid, a layer of high voltage DC built above the current layers, and it would be designed without constraints of borders. The injection points, connection points would be where they make sense from the electrical point of view. I have to finish. Let me see the time. I have to finish. Just saying that it is the theme of the day that the energy market needs to be redesigned. ACER, which is the Association of Regulations, have several points where they think it needs to be redesigned. I'm not going to go through them. Just saying that why I see a difference with what I think, and it was proposed in Spanish and Portuguese non-papers, is that they don't consider the capacity markets. The marginal market is a market of only energy, and I believe that a system with lots of renewables needs to have a capacity market, where someone is paid just to be there to start operating if it is needed, for instance, because there is no wind and it's night, there is no solar energy. I do believe it is the way to go. The example I have in my mind is an hospital which has a backup diesel in the basement, which hopefully will never need it, but it is essential when the mains fail, the grid fails, and of course for being there needs to be paid. It's what I say, it's the example I have for the capacity market. Really finishing, there are a lot of challenges in the new systems: stability, a lack of inertia, resource variability, new connections. Power flows will change a lot, namely if you put a super grid. Demand side resources will need to be integrated. The consumer has to be empowered. There will be big data. There will be big data, and flexibility will have to be unlocked. Thanks for listening.
Thank you so much, Antonio Vidigal, for your explanations, ideas, and also for your provocations that you brought to the session. I would like also to remember you that do not forget to add your questions in the Q&A. We are going to take some time in the end of the session to go through all of them. Now let's move for the second presentation. by João Maciel about the R&D challenges towards a greener Europe. João Maciel is the managing director of EDP's Center for New Energy Technologies, dedicated to apply R&D in the energy sector. He was former technology development director of EDP Inovação. João served on the board of other EDP R&D initiatives, namely the Wind Float project. He has 20 years of experience in working in the energy sector and has been involved in several innovation and R&D projects. João holds a degree in electrical engineer and power systems from Lisbon University, an MBA from the Portuguese Catholic University and Nova School of Business and Economics, and an advanced management studies from London Business School. João, the floor is yours.
Thank you very much, Gisela, for the kind introduction. Too long. And thank you especially to Antonio for the inspiring session and for sharing this thought-provoking presentation with us. Let me try to keep up. I will try to pick up where Vidigal ended. So my objective here was to talk a bit about R&D challenges. So things that we need to do in order to address the situation that Antonio so well described. But before that, I'll just wanted to make a brief introduction on, let's say, on the European context as well, and a bit on R&D programs, because as you know, R&D and public funding many times come in pair, and so I would like to make a short reference to this, and then I'll jump into the challenges that I wanted to address. So, I mean, we all know that Europe has long realized and has been on the forefront of climate change fighting and energy transition. European academia, European companies have pioneered renewable space. We all know this. In fact, I do believe that renewables and this, let's say, this energy transition industry, if we can call it like that, is an area where Europe can effectively differentiate from the United States, from China, from the competition. And so, I mean, Europe has realized this, and also, for example, on policy and regulation, has been on the forefront of climate and energy regulation. It all dates back from the 90s, where the first, let's say, the first climate policy was released. But more recently, we saw an acceleration in policy, in regulation packages that promote the energy transition, decarbonization, all things that Antonio has been talking about. I'm speeding up a bit because we need to make up for the time. Let me just highlight a few of the main programs. For example, the European Green Deal, which has set this ambitious goal to be the first climate neutral continent by 2050, complemented by this Fit for 55, which later led into the first European climate law signed in 2022, setting ambitious goals to have 55% greenhouse gas reductions by 2050, which is now being anticipated through the REPowerEU to 2030, and also with ambitious targets on renewables. And perhaps also mention the Clean Energy for All European packages as almost outdated, because it was launched and signed some time ago, but it was also emphasizing a lot the topic of decarbonization, growing ambition, the just transition, and also putting the European citizen in the center of all this, let's say, of all this change. One thing I wanted to highlight, sorry, back one. Wanted to highlight is also this. We see this as a great opportunity for Europe. I mean, this energy transition, in the sense that it will be for sure a cost to adapt to all the needs that we need to do, but the cost of doing nothing is much higher. And we do see a huge industrial opportunity. And as I said, Europe has pioneered the space, so we have, let's say, an edge when it comes to addressing the climate transition industry, if you can call it like that. On EU funding, again, in pair with the policy and regulations, funding has also been, let's say, a reference in Europe, funding for R&D and innovation. I'm highlighting here just two programs, Horizon Europe and the previous framework programs are, let's say, a old reference in research and development support, or recently related with the pandemic, this Next Gen EU program, or the programs like Innovation Fund, etc. There is a myriad of programs that can provide you with support for R&D and innovation throughout, let's say, the project, let's say, the technology development cycle. But the other thing I wanted to note is that across time and now with the recent budget as well, a huge proportion of the budget is being allocated to energy, to climate, to energy transition. Let's say the breakdown here is natural resources and environment. This also includes energy, but from the approximately 2 trillion euros of investment until 2027, around 4 billion will be dedicated to natural resources and environment, and this includes energy. But let me jump to the challenges, which is what I wanted to talk to you today. So we all, from what Antonio said, let's think about the future for a second. The future will be driven by renewables. Renewables have a number of specificities, as Antonio said. They are variable across time. They use a lot of space in the sense they are not as energy dense as fossil fuels, for example. They are distributed by nature, and this future we also imagine it with more relevance of the participation of the citizens, of the people. Grids will still be there. I mean, they have an increasing role in stabilization, providing robustness and stability of the system. I mean, we also need to acknowledge that digital is also introducing many enablers to this transition that we want to make on the energy side. So I will dive into 7 challenges. I'll try to make it brief so that we can then take the Q&A to have a broader discussion. But the first topic I wanted to mention was we are calling it sustainable renewables. What do we mean with sustainable renewables? With sustainable renewables, we talk about, for example, we know that renewables use a lot of space. As I said, I mean, renewables are not as dense as other forms of energy. Just to give you an idea, for example, this latest project from Iberdrola that was recently announced, the 1.2 gigawatt PV farm, which is being developed in the Alentejo region, will use 1,200 football pitches, as we all know. So it's a huge area. And if this is not properly managed, this may be a constraint for renewables in the future. And so, well, to deal with this issue of the space, there are basically a number of trends. But for example, one is agro-photovoltaics, which is this combination of renewables and agriculture used to be able to combine renewables with agriculture, or hybridization. So on the same space, for example, use wind and solar and combining the generation of the sources, which, by the way, as we saw from Antonio's presentation, this complementarity is also good and helps us in balancing the system. Other topic having to do with sustainability of renewables is we need to start thinking about end of life of these assets. So, I mean, some wind farms are coming to the end of life. Some have already come to the end of life. The same with PV. And so we need to think what we do with these assets at the end of life. And also for the new builds, we also need to use new materials, etc., that mitigate these issues when they come to the end of their life. So recyclability, end of life issues, these are also topics that we wanted to address. There is money available. We looked at this briefly, and for Horizon Europe alone, around 70 million until 2024. And we've highlighted here one project called EU Scores. We're trying to do this kind of hybridization of, in this case, it's offshore, but it's an hybridization between offshore wind, floating PV in offshore environment, as well as ocean energy and green H2. Second challenge is offshore renewables. Again, when we talk about constraints on renewables, in this case on land, one idea is to go to the sea. At sea, the wind and sun are good resources. There is available space. Of course, this needs to be managed. And since we are further from people, we tend to think that also the impacts may be smaller for people, at least directly for people. And so within the realm of offshore wind, we would highlight floating wind, in the sense that this will allow us to reach areas which are further from coast and in deeper locations. And also we see here a huge opportunity with this Portuguese tender, which has now been released, to take on a, let's say, a multi-technology approach to try to attract to Portugal the most innovative technologies and try to build an floating offshore wind industry in Portugal. Second is floating PV. So as we see floating PV in our inland developments demonstrating positive results, the next frontier is doing it at sea. And finally, there are other ways to produce electricity offshore, ocean energy. This may still be a long shot, but I mean, we need to keep an eye and to create some options in this area. Again, money available, 200 million in Horizon Europe until 2024 for emerging renewables. And we've highlighted, for example, Pivot Buoy, which is one of the projects we participate in, which is an innovative floating foundation, potentially very, very low cost, which is currently being demonstrated at the Canary Islands. I'm coming to the core of the system. So energy storage and flexibility. As Antonio so well demonstrated, renewables are variable by nature, and so this needs to be managed. Also, by definition, at times there will be overcapacity. If we go to these extreme scenarios, many times there will be overcapacity. And this overcapacity we either curtail or store and manage, as Antonio was saying. So some of the key challenges that we see here, of course, one is we need to work to make sure that these renewable energy assets, coupled with power electronics, which is by the way they connect into the electricity grid, with the right algorithms, with energy storage, are able to provide these ancillary services market, these capacity markets that Antonio so well described. When we talk storage, we talk, of course, different time scales. We talk, for example, pumping or compressed air for longer or seasonal storage. In some scenarios, this may be needed in specific regions, for example. When we talk batteries and demand response, for example, we talk about, let's say, the intraday scenario, or we can even go for, let's say, for faster response mechanisms. For example, supercapacitors, hybridized with batteries, etc., technologies that are able to respond faster. Other challenges, of course, to adapt to grids, to host variable renewables, and as well to deal with variable loads, because load response is also a big trend. And finally, as Antonio said, there is, of course, this issue with revising the energy markets. The market that we have, the marginalist market that we have, was not designed for renewable technologies, and so we really need to focus on developing these capacity markets that so well were presented. Around 300 million on Horizon Europe until 2024, and the project we've selected here is a project which was concluded, called Project EU SysFlex, which is a project that created, let's say, a virtual power plant in Portugal with promoting coordinated management between hydro, pumping and generation with the wind. And this could be further scaled if we take one step forward. Green hydrogen. Green hydrogen is sorry. Yes. Green hydrogen. So the rationale for green hydrogen, as was said already today, is that we need to. The idea is to use excess renewables to generate green hydrogen, which otherwise could be curtailed, and by doing this, increasing value. And so green hydrogen has been following a number of challenges. The first one I would say is we need to mature the electrolysis technology to make it more efficient, more competitive, and also to start scaling it so that technology evolves and the cost comes down. We also need to work on demand side, in the sense that we need to find the most valuable uses for green hydrogen, and there's also a behavioral issue. So we need to convince industry that green hydrogen is suitable for their industrial processes, and we need to find what are, let's say, the best fits. And finally, there is this infrastructure challenge, which is there is no dedicated green H2 infrastructure. The first approach would be to use it blended with natural gas on the natural gas infrastructure. There are of course some challenges for this adaptation of this infrastructure. On grids, I mean, we talked about it briefly when we talked about flexibility, but the idea is that we need to integrate a huge amount of renewables on our grid. Antonio mentioned the super grid concept. Indeed, there are many talks about using of DC grids or hybrid DC AC grids to be able to more suitably host a huge amount of renewables. So this is a hot topic in research in Europe these days. Other is the fact that electricity will increase because electrification is part of the energy transition equation. For example, electrical vehicles, industry with demand response with variable loads, electrification of heat. So many variable and increasing electrical loads in our grids. And so grids is also continues to be one of the important topics in research in Europe. We saw around 160 million in Horizon Europe until 2024. We've elected a project focused on developing digital tools to enhance resilience in our grids. But there are many buzz around this. For example, this digital twin for the European grid. There are many active calls focusing on grids at this moment. We had to come to, let's say, to the distributed side of the equation. The new energy world will be distributed. People are part of this equation, and it will also to a large extent electric. So a number of challenges. We need to make sure that distributed renewables, namely solar, work for clients and energy communities, namely people that live in cities, etc. We need to make sure that on the business model side, we are able to make solar work for all people. There is, I would call it the platform challenge, in the sense that we need to make sure that we manage all energy and flows within these energy communities. And third is again the topic of mass adoption of electrical vehicles, one of the most important and biggest loads that we will see coming into our grids. So if we put together distributed resources and mobility, we see around 500 million until 2024. And we've elected one of our smart cities projects, which try to develop a number of solutions with integration of PV in buildings, solar energy communities, peer-to-peer platforms, etc. A number of solutions that will for sure be part of the equation. And finally, a word on digital. We needed to come here. Digital is becoming ubiquitous, as energy will likely be in that extreme scenario. And so, I mean, the energy sector for sure will be impacted. Proliferation of devices, IoT, computation, AI, data is there, and we need to make it work for the energy sector. So we've elected a number of challenges. One is we need to put computers and AI to extract value from data and enable participation of people in the energy markets. Other is this interoperability challenge. We need to make sure that all devices communicate and that we have the right balance between distributed and centralized processing intelligence in the energy system. And finally, this all needs to be safe and privacy protected. Again, 250 million until 2024, and we've elected Project TARDIS, which developed a use case on electric mobility and distributed energy resources with, let's say, with distributed processing at different layers of the, let's say, of the system. To conclude, before I open, and I mean, I'm being too long, I know. This is just a recap. Energy transition, it's really now. Renewables will be driving the system. Renewables are variable and abundant, so they need to be managed, and their storage will be part of the equation. A lot of electrification, grids will still be there and will be a source of stability and resiliency in our system. And digital, for sure, is one of the biggest levers that we could have in our energy transition. The word to you, Gisela. Sorry for being too long.
Thank you, João. No worries. It's always interesting to hear your thoughts and ideas. So thank you so much, João and Antonio Vidigal, for your sharing your interesting insights and views. We have a lot of questions from the audience. Maybe we cannot have time to answer all of them. So maybe I will encourage you, João and Antonio, to answer some of them offline, because we don't have time to go through all of them. But still, I think we can take 10 minutes more from your time. So I'm going to put here the first question that we have to Antonio Vidigal. Which is from Juan Adam Laguna, and it's about the Tony Saber view. So supposing we have a superabundance of solar with low storage needed, won't curtailment highly increase if solar costs cost and price is around €0 per megawatt? With such curtailment, who will invest in solar in that scenario?
No, the idea, first, it is difficult to answer in a very short time. I invite you to read his book or his publications, which he has many. What he says is that we are on the verge of a change of model. And the guy is interesting. He is an economist and futurist from Stanford. And I think it was the first person that 10 years ago said that electrical cars would replace internal combustion by 2030. There will be no he missed it by 5 years. What he defends is that on a super abundant energy model, there are many things that you cannot do these days because electricity is too expensive and new loads will appear. It's what we defend. And for Portugal, I see, for instance, producing water from salt water. That we could irrigate the whole country, new cultures, more food, added value in agriculture, completely decarbonize ammonia, which is used for fertilizers, decarbonizing everything, because things which are not viable today, even green hydrogen is not completely in the money. What he says is everything will become in the money, and more things can be done. And it basically it looks crazy, but I spent my life working between IT and energy. And when people told me that I would have a computer bigger than the one I worked in when I went for EDP on my pocket, and this is 300 times bigger than the Univac 1106 I used to work when I joined EDP, would believe. And I do believe that that solar has the same ingredients that IT, then computing, that can follow a similar learning curve, similar to the Moore's law for computing. And if that's true, it will be disruptive.
Yes, for sure. Thank you, Antonio. I also have a different question for you. Let me check here. Can you comment on the possibility of connection of the X-links with the announced 10 gigawatts offshore wind farms in the Portuguese coast?
I can just as I can comment everything, but I would like to call the attention that all the opinions are my own, no,
Sure.
they are not EDP News or EDP or anyone. They
No,
are
no,
my
no.
own.
It's your views, of course.
It's just my views and what I think, but really think. I think that is a possibility. More than that, there is lots of wind in Biscay, in the Biscay, in Biscay Sea, in the Biscay Bay, and that area between the north of Spain and UK. And I believe that the cable or this or other cables could collect wind energy from our coast, from the Biscay Bay, from the. I do believe it could not, but the word is to the promoters. And I never spoke with promoters. Don't intend to just put. It is not. It not intend to speak with them, but the idea is to this or another cable and to think about sending electricity from here to the UK, and UK is a very good hub because then it is connected with Norway, Germany, Netherlands, Denmark. Has cables all around, reaching reaching
Yes.
with a subsea cable to the UK. I would think it would be strategic.
Just
Thank
a
you.
quick comment here. I mean, I will not discuss, let's say, the technical solution, but I mean, let's say on the assumptions of this tender, given the size, 10 gigawatts, for sure we need to find out a solution for exporting renewable electricity from our country, from Iberia. So be it through sea or other form, we need to find a way for sure, because it's too much capacity in a relatively short frame. So just to emphasize what was said.
Sure. If you allow me just 1 second. I've been following that project, and what I think is that the fact that areas for 10 gigas are being developed doesn't make compulsory that it is all developed at the same time. My point is that it will go phase by phase now. As new loads appear in Portugal and so forth, perhaps with PPAs, it's how I
If
see
that
it.
is the case, makes sense. Yeah.
It's how I see it. Is you develop everything, which takes time, and then we start developing phase by phase. I believe it's what's going to be done.
Very well. So next question, maybe João, this could be for you. Can we imagine a market for capacity of storage rather than production?
I mean, for sure, and we would not be innovating, let's say, in a world scale, right? This already exists in some geographies, like the UK and Ireland. These markets which have let's say most pressing stability needs have already evolved a lot, and sophistication in those capacity markets, including dedicated calls to use batteries for grid services, are already there. So I guess that's what I would say.
Yes. So I think we can have time for one question more. This time from Ana Stinkeiro, also to António Vidigal. What do you think Portugal should do in terms of planning the power system for 2040 and 50? So in the long term.
That is a long term. I do believe that the DSO will have a lot to do. I always thought I saw the internet. I am old enough to have seen the internet appear, and I do believe that we'll have an energy web where energy and IT will interplay a lot. I see a completely different model for distribution. Further to that, I consider that Europe cannot build a castle around it, as to help the Northern Africa countries to develop. One way to do it is to build infrastructure there, and I see Portugal connected to Morocco, Morocco connected to Algeria, to Libya, and to Egypt, and everything with interties with Italy, with the different countries, and that we will have a super grid connecting both European countries and African countries. and that we will be building solar and wind in the Sahara Desert, and we are very easy going around the world. I think we can help Europe do that.
Yes, yes. So I think we have time for last question because I have one connected with what João Maciel was commenting before. So from an Sancho, do you think that the area occupied in Alentejo with PV, if it was occupied by million roofs in for instance, in Lisbon or Porto, won't be much more affordable and efficient?
I could have a try, and perhaps Antonio could complement. But I think we should try as much as possible to use the available space. We realize that the challenge is of a different nature. I guess it's much easier to build the utility scale centralized PV when it comes to building capacity, to building gigawatts and gigawatts. But ideally, yes, and we do see, for example, in some of our projects, we do see building integration PV evolving, but perhaps not at the pace that we all would like, or cost not decreasing as sharply as with the conventional PV technology. But as these technologies mature, I would say that the percentage of PV on built infrastructure needs to will increase, and ideally it should increase. But 1 million or one, I don't know what was the figure, but 1,000 gigawatts in roofs, it's a lot of area, and it's a lot of so as I said, it's more or less 1 hectare per megawatt, right? So it's a lot of space, but I mean, ideally, yes. For example, there are good examples in Europe. For example, Germany incentivized a lot the PV in rooftops, even if they don't have that as much sun as we have, because also they had this interest to develop an industry. But I mean, we can see that with policy, this can move forward.
Yes, you are right. I think I agree with you at least. I don't know if you, Antonio, would like to comment on this.
No, completely agree.
Okay, good. So we also have a couple of questions, but because we are ahead of our time, we are going to share them with our speakers, and they will reply directly to you. So it's really time to conclude. I think we all agree that we are in a non-returning point. We must use the current geopolitical situation to promote measures to overcome the energy crisis, not only in the short term regarding the most pressing issues of energy affordability and energy supply shortages that have a cascading effect in all other sectors, but also looking ahead and accelerate the energy transition. Several ideas were highlighted today during this session, such as promoting complementary technologies of renewables that also could be combined with storage, new energy market designs, capacity markets, PPPs, also the topic of green hydrogen, energy communities, the topic of electrifying the transportation like electric mobility, the digitalization of energy sector in order to enable most of the solutions that we have been talking about, the super grids and different configurations of grids to accommodate massive integration of renewables and also higher levels of consumption, enable more active customers, so on and so on. I think all these innovation channels will contribute to pave the way towards a more energy independent Europe with cleaner and more sustainable energy system with real implication in our planet to make it a pleasant place to live in. I think that's our ultimate goal. Thank you so much. Thank you, João and Antonio Vidigal, for the presentation.
Thanks a lot to you.